Hello, let's look at the dereference operator. So it's the asterisk. It's crucial when working with references to access the underlying values. This is an article I put together on my redandgreen.co.uk website. I've collected this from a couple of books and run it past ChatGPT as well, just to kind of do me some nice sentences. What we've got is for loop. So for element in the haystack, if element if LE equals needle, print the LE. This won't compile because the loop would consume the vec. So this is all about knowing what lives on the heap and what lives on the stack. The problem we've got here is that the vec gets used up within inside this for loop, so it gets eaten. So you can't print it. If this line wasn't there, it would compile. So the compiler offers us this suggestion. It says, try doing a borrow on the haystack. So if you take that advice, put the borrow before the haystack. So you borrow the haystack. If LE equals needle, print. It still won't compile because you're trying to find a borrowed integer equal to an integer, different types. So how do you fix it? What you need to do is use the asterisk, which on line 7, we add that, and then it does compile. So probably best thing to do is just copy and paste this code and try it out in Rust Playground, really. So that's using a for loop, which is one way of iterating, but with Rust, we've also got the lazy iterator, the iter. When you want to use that, that also needs you to dereference the element. So if the dereferenced element is equal to the needle, then it works. So one of the things when I started learning Rust was I got confused because you didn't have to dereference when you were printing things. And having done a little bit of C in the past, that didn't quite make sense. So printing macro automatically dereferences a reference. So it allows you to directly print the value. Internally, it uses the standard format display trait, which is implemented for many types, including references. This enables seamless display without explicitly using the dereference operator. Okay, so we've looked at for. With iter, I'm not going to talk about iter moot. I'm just going to talk about iter. So in iter, it's a method that's often used to create an iterator of a collection, allowing for controlled and safe traversal of its elements. The primary scenarios where iter is beneficial include, so read-only iteration. Again, we're just talking about iter, not iter mut. When you want to iterate over the elements of a collection without modifying them, using iter provides immutable references, so references to each element, ensuring the original data remains unchanged. Working with borrowed references, when interacting with functions or methods that expect references rather than ownership of the collection, iter allows you to provide references to the elements. So it avoids you transferring ownership, which means you can still use the original thing afterwards. So in summary, iter is useful for controlled read-only iteration, working with borrowed references. And again, it ensures that you can still use the original vector or the array afterwards. So why do we need to use the asterisk, or why do we need to dereference numbers if they're on the stack? Because when you have reference to a primitive, you don't need to use the dereference operator when comparing or using them in most contexts, because Rust actually performs dereferencing, known as deref coercion. I'm going to just gloss over that because I think that's probably slightly beyond what we're interested in right now. So there are cases when you need to use the asterisk deref explicitly. For instance, when working with more complex types or custom structs. In summary, for primitive numeric types, In common situations, Rust's automatic dereferencing simplifies code, but in some cases you might still need to use clarity or when working with custom types. Also, when you want to modify a value in place, so if you come from that scripting language, you probably won't have done this, but if you've done a little bit of C, you'll know that you can actually modify a value in place without making without copying it and modifying the copy or anything. So when you modify a value in place through a reference, so the reference is like a pointer. A reference is similar to a pointer in other languages. It's a way to refer to a value without taking ownership. So you don't take the ownership. Because you haven't taken the ownership, it's read-only. Because it's read-only, you can't modify it. But what if you want to modify it? So there we go, the reference. You put the asterisk before the reference, and that's where you're going to be. If you're ever incrementing a number, like an integer or float, or decimal, sorry, not decimal, a float or an int, like a U8, I32, whatever, you'd put the star there. So what you're basically saying is modify the value at that reference. So the reference is mutable version of the number, which is 42. So you want to modify it. So yeah, then you get modified value is 52. This is probably like drinking from hosepipe. Probably the best thing to do is look at this article and just kind of digest it in little lumps, chunks, bite-sized pieces, whatever you want to say. And yeah, so a reference is like a pointer in other languages. Do they contain anything else? So no. The reference is basically just lightweight and it points to the memory location. The length and the capacity you might also hear or see about a pointer plus length plus capacity. That's what you get with a vec or a string. So if you need to know the length or capacity, you typically query those properties directly on the collection, not on the reference to the collection. Again, a lot of this is kind of very theoretical. So yeah, probably better just to actually type it in and see what happens. So there we go. The conclusion even. So I was distracted by the photo. In Rust, the dereference operator is used to access the value behind a reference. So it's essential for modifying values through references and iterating over collections, while automatic dereferencing simplifies operations on primitive types in certain contexts. So in general, when you're working with numbers, it's dereferenced automatically. So yeah, try these examples. It's on my website, redandgreen.co.uk. Probably best to start here. Start with the first example. Work out why it wouldn't compile. Look at the compiler error message. Act upon it. Then find the second error. And ultimately, you can then find a solution if you're just using a for loop. And then you can go on from using the for loop to using iter. So there we're actually using, so we're using for there and iter. So you can combine them. And then, yeah, just remember that some macros actually do things that you're not aware of. So in actual fact, the println is actually dereferencing for you. A good thing to do is actually try and do things explicitly and see if it still works. And then obviously if you want to print a pointer or something, then instead of doing colon hash question mark, you can do colon P and pass in the pointer. But yeah, probably best just to actually experiment. Copy this code just for some practical stuff. Let's just do that now. Cargo new ref cd ref. I'll make this bigger as well. Oh wait, yeah, cd src nv main ggdg gone, paste in, save, compile. And there we go, that's the error. So, and there we go, that's what you see on my web page. So yeah, copy and paste from the example on the web page. And yeah, if you get these errors, remember the Rust built-in. So I've developed or I wrote a little modification in my bash RC, and also I use bat. I think I called it Rex. That was in a video a couple of weeks ago. I've forgotten already. Rex EO382. There we go. So a variable was used after its contents have been moved elsewhere. And this is probably one of the most common errors you will get to start with in Rust. Yeah. Sometimes we don't need to move the value. Using a reference, we can let another function borrow the value without changing its ownership. Yeah, so rather than clone, which is sometimes cloning is cheating, use the ampersand. That's not extra nice to read. So yeah, come back to my nice website and have a look at that to start with. So thanks for watching. Hopefully this is a good reference, no pun intended, for you. So redandgreen.co.uk, have a look at the Rust thing, and I'll put the link in the video description. This is quite a lot of theory, but I think occasionally Rust does actually require a lot of theory. But I think this is a really good example because it shows you the first error, you try and fix that error, then you get the second error, then eventually you fix it. And then I've shown the alternative way of doing it using iter. And then we've talked about iter and how iter takes a reference. So basically it's like a read-only iteration over the elements in a array or vec. So thanks for watching and back soon. Please comment, thumbs up, subscribe, do all the usual things that everyone nags you to do because, yeah, the algorithm and everything. If the algorithm doesn't find these videos, they get about 10 views and then one day I'll just give up and go and, I don't know, go and drive an Uber taxi or something. I don't know. But yeah, there we go. Thanks for watching. Cheers. See you soon.